probability problems using permutations. Okay, let's consider this question here. 3 cards are drawn from a deck without replacement. What is the probability that there will be a king, a queen, and a jack in that order? Well, if you think of what you learned in lesson 1.5 involving independent and dependent events and conditional probability, then the first event in this compound story is drawing a king. And there's 4 kings in the deck, and at the time of your first card drawn, there's 52 cards in the deck. Then the second simple event involves drawing a queen, and there's 4 queens in the deck, and after the first card is drawn, there remains 51 cards in the deck. And the final event in this story is drawing a jack. And you draw a king, you draw a queen, the jacks aren't affected. Drawing a jack is independent of drawing a queen or a king. So there's 4 jacks in the deck. However, the sample space is dependent because the cards are not being replaced. It says without replacement. So the sample space on the third simple event is dependent on the first and the second, just like in the second event with the queen being drawn, there remained 51 cards. Now with the jack being drawn, there remains another -1, which makes 50 cards remaining. So overall, the probability of drawing a king, a queen, and a jack in that exact order is 4/52 for the king, times 4/51 for the queen, times 4/50 for the jack. And when you multiply the fraction before you reduce, which ideally you shouldn't reduce, is 4 possible ways out of, 64. 64 possible ways. 4 times 4 is 16, times 4 is 64. My apologies there. 64 possible ways to draw a king followed by a queen followed by a jack out of 132,600 possible ways of drawing 3 cards, regardless of the restrictions that they're king, queen, and jack. And that's the probability involving independent and dependent events, and the concept that the second and third events, they're conditional, they're dependent on the first event. So that's something you learned in chapter 1, lesson 1.5. Okay, next, let's reconsider this probability problem using permutations. So, in chapter 2, lesson 2.3, you're learning about permutations and how there's n objects and r objects are selected. So in the case of the kings, there's 4 kings available and only 1 is selected. So that becomes the permutation of 4 choose 1. And in the case of the queen, it's the same scenario. There's 4 queens available and only 1 is selected. So that becomes the permutation of 4 choose 1. And in the case of the jacks, again, there's 4 available and only 1 is selected. So that becomes the permutation of 4 choose 1. And since it's a compound event, the first card is selected and the second card is selected and the third card is selected, makes this a compound event involving 3 simple events. So we use the fundamental counting principle and multiply the outcomes of each simple event since they're all involved. And that equals an event space of 64, just as we've seen in the first method. So 4 times 4 times 4 equals 64. And each of these answers, for the first one, the permutation of 4 choose 1 equals 4. 4 choose 1 again equals 4, and for the last one, 4 choose 4 permutation equals 4, and we multiply the three simple event outcomes to get a total compound event number of ways for a king, queen, and jack to be selected in that order of 64. Now we consider the sample space separately, and there's 52 cards available in the deck, and because in that order was referenced, it's a permutation, order's important, and 3 cards in general are being selected. So it's the permutation of 52 choose 3. And 52 choose 3, permutation equals 132,600. We already established that the numerator equals 64, and there you have the probability of selecting a king, queen, and jack in that order without replacement using permutations.